one thing about as I've gotten older, I can appreciate more history, and the history of how we understand our solar system is, I think, kind of an interesting one. So I'm going to talk you through it a little bit. But back in the BC time, we have a couple of, I'll say quasi-scientists, because the scientific method approach to understanding natural phenomenon was not entirely in place, but it was budding, let's put it that way. What we used to think, and what these guys thought, I'll put E for Earth, is that actually everything orbited the Earth. So it would look like the sun actually was going about the Earth. That's my sun here. Okay, the planets orbited the Earth, the stars orbited the Earth. Okay, everything orbited the Earth. This is what we call a geocentric or Earth-centered model. Now, we know that that's not the case today, but based upon observations, that's what the case they made for it, okay? The other thing, and this actually was a player in what Kepler's work, another person that helped us understand how our solar system worked, was that at the time, the heavens were perfect. Of course, this is all the heavens. And so any motion and everything must be a perfect circle or a perfect sphere. All right. So now, as far as everything orbiting the Earth, the planets usually, I'll go ahead and make a, okay, the word planet actually came from the term wanderer, where most planets usually go, or I should say planets usually go eastward. Eastward against the background stars. These are background stars. Okay, now not in one night, but over the period of time. So here we have June to November, and we can kind of see this eastward motion here and the eastward motion here. Okay, and that would make sense if Mars is orbiting the Earth. I know it sounds silly to think about that, but what they couldn't explain was this right here between July 30th and September 29th. And so that right there, this kind of what we call backward motion, is what we call retrograde. Retrograde motion. And I like the video. If you're listening to these in order as I intended, you actually watched a video where somebody explained retrograde motion, and she called it apparent retrograde motion, because does Mars really go backwards? No. But it's this apparent retrograde motion that people could not explain if you just simply put the Earth, if you have Mars orbiting the Earth. Why does it appear to go backwards at times? Okay, and we'll get to that here in a minute, but it's what the video explained. So here we have actually somebody who did explain retrograde motion with a geocentric model. So here again, we have Earth in the center of everything. We have, of course, the sun orbiting the Earth, and here this is this kind of this general path of this orange right here. That's a planet orbiting the Earth. And what Ptolemy said, and it was kind of the last-ditch effort before we switched gears from putting the Earth at the center of our solar system to putting the sun at the center of our solar system. What he said is he kind of made it complicated. He said that the planet Mars, for instance, okay, will go this way for a while, and then it will have a little epicycle, and it will do a loop-de-loo, and at this point, this is the retrograde motion, and then it will go direct, and then it will go retrograde, direct. Okay, those little kind of epicycles, we called epicycles around an epicenter, that's how Ptolemy said, yeah, that all works. Now, Ptolemy actually got into the territory of something called Occam's razor. And Occam's razor says that if you come up with an explanation that's too complicated, you're probably off track. So Occam's razor is sometimes the KISS principle. What KISS stands for keep it simple, stupid. Now, I'm not saying that Ptolemy was stupid. He was not stupid, but it was just a complicated, he went beyond being simple. So then enters Copernicus. So Copernicus was a turning point from Ptolemy. Copernicus, and he was not the first to say this, but he actually came back up with it. And it was kind of, how do I say, not necessarily welcomed. Because what he said basically is not the Earth, but it's the sun, and the Earth orbits the sun, Mars orbits the sun, Jupiter orbits the sun. Okay, and so that is switching gears from a geocentric or Earth-centered model to what we call a sun-centered, otherwise known as a heliocentric model. Helio meaning sun. So Copernicus actually, and again, he wasn't the first one, but he went and published work. And what he said was, and again, this is where I hope you watched the video to explain this. He said that the reason that, I'll kind of draw your attention down here. He said the reason that Mars, this is Mars is the red one, Mars appears to move retrograde in against the background stars is that Earth actually, and we're going to see this coming up, this is one of Kepler's, this is one of another person's laws, is that Earth moves faster and Mars moves slower around its track. So because of that, Earth moving faster, it is going to do what we say overtake Mars. And so it's during the overtaking, which would be kind of what, 3, 4, 5 here. Okay, 3, 4, 5. It's during the overtaking that we actually see Mars go westward. That's retrograde. Otherwise, Mars will have what we call direct motion. Okay, so like I said, I hope you went ahead and watched the little video. It will help it make sense.